Hello, and welcome to Building Sustainability Podcast. I'm your host, Jeffrey Hart, aka Jeffrey the Natural Builder. Building Sustainability consists of conversations with designers, builders, makers, dreamers, and doers, exploring the wide world of sustainability in the built environment by talking to wonderful people who are doing excellent things. Hello, and welcome to episode 54. This is the first of a two-parter with Craig White of White Design, ModCell, Agile Homes, and lecturer at University of West England. This episode is a more general overview of what inspires his designs, choices, and why he chooses straw as his preferred insulation. If you're listening to this on the release day, then the part 2 will be out very soon as I can manage. Expect it in the next few days. And that episode focuses more in depth on his work with ModCell, a panel-based straw bale building company, and Agile Homes, who have a unique way of delivering affordable and healthy homes. So stay tuned for that. Okay, what news? Firstly, last weekend was the mass trespass of the South Downs. 300 of us went for a glorious walk in the countryside, and we had a picnic on some council-owned land that is rented out to tenant farmers, and thus people are not allowed on that land, even though it is technically public land. So we sat down, we listened to talks from botanists, poets, travellers, hikers, and even friend of the podcast, Beans on Toast, played a new song about the campaign for the right to roam. So this was all in aid of Landscapes for Freedom, which are campaigning for the right to roam on the South Downs, and a part of the national campaign for the right to roam in England, which will give access to the countryside to the entire population, unlocking the mental health benefits and the wonder of nature for all. It was great to catch up with another friend of the podcast, Nick Hayes, author of Trespass, Crossing the Lines That Divide Us, and Flo Hamer of Tiny House fame. I even got to meet some lovely fans of the podcast, which was a treat. And I got to meet an Instagram friend, Georgie, whose work I'm a big fan of. Georgie's project, Building Bluebell, it's a work of art. I suggest you check it out. I'll put a link in the bio. And then I topped off the day by jumping in the sea. I mean, could there have been a more perfect day? So the big news was competition news. July has been the big Patreon subscriber drive, with all new Patreons for July being in the draw for a whole pile of handmade prizes from some of my favourite makers. Those are John Mullaney, Jeff Hannis, Dave Cockcroft, and Isla Middleton. Again, links for those makers in the bio. So thank you so much to all the new patrons. Your support really makes a huge difference to me and really keeps the podcast going. There are all the regular running costs to pay for website hosting, equipment, studio hire. But also your support gives me a little money to pay for the time that I dedicate to this podcast. So really, thank you. It helps so much. Right then. So, new patrons, and apologies for any mispronunciations. We have Spoons by Nature, Eugenia Mompo, Steve Richards, Ron Fick, Miriam Johnson, who's a very talented stone carver, Talene Josephson, who you may remember from the Bite Size episodes. We've got Kirsten, Tony Lotter, Tom Lopez, Charlotte Workman, Pete Lloyd, Tom Wilmot, Mark Fletcher Co., Rosie Mockford, Izzy Byers, Becky Gilling, who's on the Prince's Foundation course at the moment. We've got Katie Renker, Gideon Marriott, Simon Lovett, Faye Thorley, hello Faye, Alice Favre, Ian Dickinson, and Tom Hughes. Thank you so much to everyone. It's such a big list of you. Thank you. That really makes me very pleased. A special shout out to Miriam and Alice, who have both gone for the £5 level, which means that they'll be getting a hand-carved spoon from me. Okay then, let's do the draw. I'll fire up the old laptop and generate the random number. It is number 7, which is Kirsten. So congratulations, Kirsten. You have won a whole bundle of prizes. I will get those out in the post to you as soon as possible. There's a second prize draw for a special bowl that Flo Hamer has turned for us. And that's for all the existing patrons who had subscribed before July. And so the winner of that is number 17. That is Henrietta Dale. Congratulations, Henrietta. I will get that bowl in the post to you shortly. Thank you. Well, I really, really appreciate it. I don't think I can say that enough. If you are listening now and you think you'd like to support the podcast, then go to patreon.com/building sustainability and you can sign up there. And not only do you get to feel good about supporting, but you also get access to 9 hours of bonus audio. So a little treat for you. Okay, I think that's enough from me. On to Craig White. I'm not going to say anything at the end of this episode. I will do a full roundup at the end of the next one. So enjoy.
I'm an architect by training and established the architectural practice White Design on the basis of, this would be 22 years ago now, trying to deliver low energy, environmentally friendly buildings. The language was the language we used then. Today you would say sustainable low carbon, and you might add triple bottom line into that. That practice managed to hold onto that vision to take a journey into how do we deliver low carbon buildings. And that naturally took us into assessing embodied carbon, looking at health and well-being, looking at the impacts and provenance of all the materials we were working with. And you start to naturally move towards renewable materials, and because they're made of carbon, we can build with carbon. That's the kind of language I would use today, and they are part of, if you like, the circular economy. Although 22 years ago that was still not in common parlance. And then, as a part of that commitment, being a designer of buildings is one thing, but being a maker of buildings using those materials is not a natural step for everyone, but became a step for us. And we set up ModCell, which is the business that makes prefabricated straw bale building systems. We've then arced all the way through to today, where I have, with colleagues, set up a new business called Agile Homes that brings together that design, make, and low carbon agenda using renewable materials, which include timber and straw.
Okay.
So that would be, so we make buildings, we make low carbon, affordable homes for people in housing need out of natural and renewable materials, timber and straw.
Fantastic. So you say renewable materials, and I would understand that as kind of biomaterials. Is that?
Yes, the language evolves all the time. So bio-based, nutrient cycle-based materials. So for me, renewable materials allows it to be considered in the same kind of language set as renewable energy.
Yes.
So if you like, we're riding off of that. Renewable energy, people understand. Renewable materials, you could then describe. Bio-based opens up another world as well, which includes palm oil and heavy industrialized processes as well. So bio-based, if I'm doing research bids, renewable materials, if I'm talking to
real life people,
people in the street.
Yes.
Yeah. Normal people.
Fantastic. And then straw seems to be one of your sort of key materials.
Yeah.
That's fair? Yeah.
Yes.
why? What's the draw of straw for you?
So straw is a byproduct or co-product of making our daily bread, grown wheat straw, if we focus just on wheat straw for the moment. And that was also a really important part of the choosing straw, as opposed to some other field crops that you could use, in that it was definitely by or co-products.
Yeah.
And that means effectively we're picking up something which would have been described as waste. We used to burn straw. So, I mean, burning will put nutrients back into the soil, but it also puts carbon into the air. And so for me, the choice of materials where possible should be byproducts. And then we are starting to get into the material provenance sector, which say it is better to use by and co-products than it is to insist on a primary field crop product. So the worst example of that is palm oil and the decimation of forestry to introduce a new type of crop into a developing economy that destroys nature. Mm-hmm. We specifically seek to avoid that.
Yes.
So, and then
go on.
Super insulating. We can't get the insulation value all the way up to the likes of foams and polystyrenes, but they are also toxic for our environment, as Grenfell tragically demonstrated. Mm-hmm. And so a bio co-product being brought into a way of building which delivers low carbon outcomes in use and is made of carbon itself. So it's actually sequestering or capturing carbon. Nature does that, and we do the storage. So those are the kind of motivators for us.
Fantastic. Did you consider other renewable materials? I mean, so when you've said that co-products, I was thinking about hemp, because that's actually planted for its purpose. It's not a co-product as such.
Yep.
Was that something you considered, or?
Yes, we've worked with hemp in the form of hempcrete. Mm-hmm. We've done prefabricated hempcrete panels, and we think it's wonderful. And what we found, though, our preference became in the early days of Mod Cell, straw bale, lime render on the outside, lime render on the inside. Felt to us a more optimized combination of two materials, delivering a slightly higher performance wall in terms of its U values. Hempcrete is great. I have no problem with hempcrete at all. But for us, it delivered a combination of outcomes which were better.
Yeah. And then you're involved with, is it Stramit, the compressed straw board as well?
Yes, so Stramit has a very interesting history. Okay. We acquired the technology rights to manufacture Stramit, or compressed straw board, as Stramit is a kind of brand.
Okay.
Compressed straw board is the kind of technical description of that. But the technology around that, all the patents have expired. So we've got all the, if you like, the shop drawings for the machines. But we were introduced by the son of the founder of Stramit, John Moseson, to Ecopanely, Jan Baresh, out in the Czech Republic. And it was very obvious that to reset up a manufacturing capacity to do that in the UK would be many, many, many millions of pounds of investment without a market ready to pull it. So we preferred to partner with Jan Baresh at Ecopanely. So we have the commercially, we have the import rights for compressed straw board into the UK, and we use that in our build systems.
It's an interesting one. My understanding is that it was quite often used to be used in flat roofs. I've been walking down the street in Keynsham, where I used to live, and saw kind of a builder's sort of pile of mess. and was quite surprised to see a
blown straw board.
Yes. Yes.
Yeah.
Why was it particularly used for that? Do you know?
Well, so we have because we know the son of the founder, John Moseson. Basically, there are 300,000 buildings in the UK that have used straw board, and 80 million square feet were manufactured in Britain.
Right.
What happened was that they were manufacturing that and then had much more control over the specification, because its first role was as load-bearing internal walls. Then between 1945, when it started, through to into the 60s and 70s, flat roofs appeared, and that particular product was sold into a distribution network, and people started using it on flat roofs, which is with a bit of bitumen on top. Those are the way they built flat roofs then. And at that point, flat roofs will fail, especially built as they were in the 60s and 70s, with not the attention to detail we might use today. Uh-huh. And then, like with all organic materials, the enemy of organic materials is water. And organic materials will naturally absorb water. And compressed straw board is a material you would choose to invent today, but it is it's not bonded using glues. It's bonded using lignin naturally present in straw. It activated by heat and pressure softens the lignin. The lignin translates to the surface of the straw and creates a high surface, low strength bond. Water on high strength. So it does what OSB or board does. If you let OSB board get wet, it delaminates. If you do the same with straw, it just does that depressingly fast. So we only use straw board. We use it in roofs, but we only use it in a completely contained 3-layer of separation to the point at which water can get in. So we design our build systems assuming water will get in and then designing how it gets out.
Fantastic.
So yes, that's its weakness. But once you know what its weakness is, you can design to deploy it where you get rid of its weakness and can work with its strength.
Yes, absolutely. I feel like I've sort of my questioning maybe has led you to be quite defensive, or sort of put you on the defensive. I think I'm.
No. I'm very happy to share all of this stuff, because when we work with organic materials, you enter into the world of decay at some point, and that's so we tend to we tend to share that information. So it's so I'm not. I hope I wasn't coming.
No. So I think it was poor wording on my part, but I didn't want you to feel like I was sort of attacking the product. I'm interested.
No. I mean, others have done more to do that than and then also it fell out of use because plasterboard appeared. Plasterboard didn't exist when Stramit was first used. We've used it as a plasterboard replacement, and then plasterboard with stud work comes in for load-bearing walls, and then you don't need what the straw board was able to do then. So it went through a kind of development cycle and a use cycle. It got used inappropriately, but that wasn't the cause of its demise. Plasterboard was.
Okay.
I think.
And do you think it's coming back, or can we make it come back?
Yes, I mean I have we use it in our buildings today, and we have using any organic material, you need to know where its failing boundaries are going to be, and then design not to get there.
Yeah, definitely.
That's it. It's the same. People, I'm sure you're familiar. If you're working with straw in the Nebraskan method or in prefabricated, you get fire, rats, insects, wolves, and pigs. Those are the questions you get asked constantly, and quite rightly, because you do not want a building that will get blown down by a wolf or catch fire or decay. So these are intuitively natural questions for people to ask, and I've just got routinely good at answering those questions.
Yes, you have. Well, I feel at ease. It's a product I want to use.
Yeah, so we're going to be building thousands of natural material, renewable material buildings. That's a challenge for all of us now to do with the climate emergency.
And do you see that as a thing that can happen? I mean, I don't see any sort of large uptake on the sort of volume house builders at the moment.
The construction industry walks into the future backwards. That's what it does. It likes to do what it did last week. It is systemically not an innovating industry. And I'm not being rude to the industry. It doesn't really want to be an innovation industry or sector, and so is really, really happy doing what it generally does. However, I would say we will see the system has changed around the construction industry, climate emergency, embodied carbon, the narratives, and the amount of interest in embodied carbon has just gone through the roof. And as soon as you start asking about embodied carbon, you start doing the calculations, and you naturally move towards timber and renewable materials. You have no other choice but to do that. So I'm not interested in what the volume house builders want to do. Agile, as a new company, is set up to build with straw in the vacuum of the housing crisis. So we are going to, I don't need to convince any other builder to build using straw. We're just going to build. That's what we're going to do.
Yeah.
So, and then the interest, though, has gone through the roof. So there's a huge demand now to know more about how you can build using these sorts of materials in a variety of different ways.
Yeah. Well, I think, so ACAN, I think the work they're doing, and I saw that you're talking on their straw natural building Zoom next week, is that?
Yep.
Yes. I think the work they're doing, and they're pushing the embodied carbon thing.
Yeah, I mean, I think people will be familiar, but a developed economy produces 45% of all a developed economy's emissions are linked to the built environment, whether that's in embodied carbon or whether that's in operation and use. And so concrete is the new coal. As we get rid of coal power stations, concrete is not a high carbon material, but we pour a cubic meter of concrete per person on the planet every year. So that's 7.3 billion cubic meters of concrete being poured annually. And at that volume of material use, it has a disproportionately high level of CO2 emissions linked to that, about 9%. So if we are going to decarbonize our future, we will have to switch our material sets. And so, for example, in Agile, we never pour concrete. We don't pour foundations in concrete of any type. We work with pads or ground screws.
What are the pads made of?
The pads are either high density, is it polypropylene, I think? It depends on the ground. We will do concrete pads, little sort of 30 centimetre by 30 centimetre concrete pads, or we're using steel ground screws, which can then be unscrewed at some point.
Yes. Excellent. Yeah, I mean, I've got so many questions about Agile, but I think we'll sort of come to that a little bit later on.
Okay. Yeah, great.
So I guess I'm interested. So you lecture at UE, don't you?
Yes, at the School of Architecture and Planning.
Yes. And what is your sort of speciality there?
Unsurprisingly, it's to do with low carbon, sustainable methods of design, and that's all I've ever taught. I've never. So, I was the sustainability guy. I generally teach postgraduate now. Up until recently, I ran a unit called Live, Work, Make. Where should we live? How should we work? What can we make? Which synthesizes all of these things. And on as far as the university is concerned, that was the sustainability unit.
The box ticker.
But today, yes, I don't want to. I'm not. This is not a challenge to the university. It's like all universities, climate emergency is declared, and then everybody goes, so what do we do now? And what do we do now is embed that into every part of our coursework. And UE is innovating in how it teaches that vertically and horizontally across. It's how it teaches architects, engineers, etc. But I think that's a little bit like trying to turn a supertanker around. It's quite hard. So what we're now seeing is fantastic activism from students. We're now also working with communities on how do we do smaller projects with communities where that is sustainability, low carbon agenda is core to it. Also societal equality, sustainability, triple bottom line stuff. And I think we will see new modules of learning emerging out of that. And then also seeing wonderful work by students themselves, setting up their own School of Architecture, the Anthropocene School of Architecture with Scott Macaulay. A recent graduate just decided, I think I need to set up a new school.
Yeah.
And fabulous.
Yeah, big fans of Scott's work.
Activism. Yeah, activism is back, and I think that's really powerful. And I'm seeing as much, if not more, push from students than I might see from the academic institution itself.
Yes, I guess. Yeah,
and I'm employed by them, and I think they're great.
Yes, get the caveats in there.
Yeah. I still want to work with them after this podcast.
Do you? Something I've seen, or sort of an impression I get from outside, is that architects, their training is about designing spaces and spaces that feel good and spaces that look good, and the actual materials and the sort of construction details and things like that is somewhat lacking from what I've seen. In fact, last week I was just talking to an architect friend of mine who couldn't quite grasp the idea of airtightness and drafts and breathability and sort of the fact that they're different things. So yes, and she's a fully qualified, very good architect. So yeah, do you think that is that still the case, or is that changing?
I think that's across the board for architecture and engineering. Effectively, there is a 20th century teaching model developed since the beginning of that century, with 2 world wars kind of in between. The teaching methodology was one of moving specifiers, designers, whatever they're up an aesthetic tree for some. Where perhaps there has been a dislocation and a forgetting of how the materiality of buildings and how they get combined. I would have colleagues shouting at me right now, but the system, that's a systems issue on how we educate. And we also put architects in particular through undergraduate and postgraduate and 7 years. And depends which school you go to. Some would say some are in, maybe more conceptually focused in their teaching and learning. Others more practically focused in their teaching and learning. The reality is we spend longer training architects than we do surgeons. And we need to reconnect how we make into the academic. And it is easier to develop an academic program which is conceptually based than it is academically. How do you mark making a straw bale wall or a concrete wall or a steel frame? So I would not be unkind to anyone having spent their time, and I could say there are architects and engineers out there who are going to have to relearn faster than what they've learned over the last 20, 30 years of their career. This challenge is so great now. And it's a very, very easy stick to hit schools of architecture with, because the demand all around is a lot. We've got to teach them about cultural theory. We've got to teach them about how does diversity work in design? How do we do that? When I was at university, there wasn't the Disability Discrimination Act, so there were steps everywhere. So there will be a reset, and what I'm hopeful of is that architects are willing to relearn as much as they are young people being taught how to do this. And so I think it's an easy stick to hit people with.
Definitely.
Sorry.
No, that's fine.
But, I think making, that's why I set up a unit called Live, Work, Make. So if we can combine those three together, then we can get better results. But we need conceptual thinkers as much as we need airtightness detail guys.
Yeah.
We need both.
Yes. Yeah. It's the holistic, all of it.
Yeah. So for me, systems thinking underpins my work, and systems thinking accepts that people will come at this challenge from different angles. How do you synthesize all that into a common purpose, which is taking 80% of our carbon emissions out of our built environment?
Yeah. I do feel bad for architects if they have gone through their 7 years of hard training to then, they're now getting the people poking and saying, go back to school and learn more.
Yeah, well, I can guarantee, I know I've got people colleagues, architects and engineers who have engineered the most amazing buildings, but they're disasters if you start thinking about carbon. So they are brilliant at one level, but have a carbon impact, which is, so what I would always, my whole approach to this is to encourage innovation and change and relearning. I don't know. The Pompidou Center is lots of steel and stuff. You could build the Pompidou Center in timber. Mm-hmm. There's no doubt about that. But then the challenge wasn't about energy use and carbon emissions. It was another set of cultural contexts in which they're working. So I think this is a challenge for everyone. How do we share the knowledge, do the unlearning and relearning? Because there's a lot of unlearning to do in our industry. Yeah,
and throughout life, I've only just, and I'm slightly embarrassed about this, I've only just stopped using plastic sponges. And this is, just a day-to-day example, because they were just so embedded in my sort of, everything I knew about cleaning dishes was in a little plastic sponge. So
being green isn't easy. That's there's a whole book on that. Being green isn't easy.
Yes,
so
absolutely. Yeah. Okay, good. Well, I wanted to ask you about sick building syndrome. I think we can start there.
Yep.
So, what is it?
So, sick building syndrome is a collection of human reactions to built environment, whether that be flickering lights, whether that be off-gassing from materials, whether that be no ventilation, so indoor air quality changing. So it's actually a collection of reactions to us as humans in the built environment, and that can also happen outside of buildings as well. Mm-hmm. Ugly buildings, beautiful buildings, that affects our way of looking. I don't want to get into that debate because that's a weird one at the moment. So sick building syndrome happens to us in lots of different ways. Basically, buildings are bad for you, mostly.
Yeah. And so what sort of things can we be doing to sort of combat that and because we've decided that we're going to be inside for lots of periods of time.
Yeah. Yes, we're kind of slightly strange as a species. We put ourselves into artificial darkness inside buildings,
but then turn the lights on.
On in the daytime. Yeah, so all of those. So there is a huge amount of contradictions, and yet our basic instinct is to find shelter, at least just to find shelter. So buildings have evolved through all of these changes. So I think there is a wonderful diagram that shows where humans are comfortable and where the built environment mitigates against that. And there are a series of triangular moisture content, sporing, temperature, air movement, air changing, off-gassing, etc., etc. So we are quite a fussy species when it comes. We have a very small window of comfort. And I think the way in which we deal with sick building syndrome is to remember the purpose of a building is to give shelter to humans, to be able to do things, or whether they're learning, whether they're living, whether they're sleeping. That effectively is a device for creating shelter. And at that point, if you start from the human and work out, and we're a kind of bag of moisture, basically, you then have to say, okay, so I've got to now work out from that human out to the point at which I stop the rain coming in, keep the warmth in, keep the heat out, or whatever we're trying to do. And then doing that in a way which keeps that human in that safe and comfortable space, but then adds to their sense of well-being and place. And then we get into the philosophical about so you could design a very, very awful building that is looking after your health and well-being, or you could design a very beautiful building that's doing the same. So, and then you get into, so what are the materials we use? If you use highly processed materials, we're likely to be off-gassing. If we're using lower and materials nearer their natural, lower processing and materials nearer their natural state, there's less risk of formaldehydes, VOCs, and things like that. Mm-hmm. So I'm talking about that because I'm systems thinking. So I'm trying to look at all of those things: light, air, temperature, humidity, all of those things. And that's a sensual question. That gets a bit freaky for some people, but effectively the architecture has to be a sensual response to the bag of moisture that we are as humans. So how do we design that? How do we design the walls to breathe, and not just vapor control, but breathe? How can we work with materials that are not producing VOCs and formaldehydes? And of course, natural materials will produce formaldehydes as well. So it's not just to say, let's build with straw because you don't get these things. You do, but they are at much, much lower levels than if you were using plastics. So for me, sick building syndrome defines the problem, but it doesn't help define the solution. So I would rather change the language to how do we design well building syndromes? And then you start at the right end of the problem, i.e. you start at the solution rather than start with all the problems and try and unhook the problems. You just start in the right place first.
Yes.
And then we go from there.
I had it described to me. Someone said that there's the what, how, why of any sort of problem, and I think the best people start with why.
Absolutely, yes, yeah, I would agree with that.
Yeah. So as part of that, so daylight is an interesting one that I've designed it for want of a better word, my house, and I'm building it at the moment, and knowing. Right. The size of windows, knowing that a window is a weak spot thermally, but that daylight is, it's important for my mental health. I've really struggled with knowing what, how much is too much and how much is not enough, and all these sort of questions.
And I think also with the rise of passive house, the means by which we numerically calculate optimal spaces, and then put a human in and then say, okay, so for Jeffrey, actually daylight for mental health is really important. And it's the same for all of us. The Human Rights Convention on Torture says if you put a human in a space with 1,000 lux and don't switch the light off, That's torture.
Right.
So we can design buildings that are deemed to be under that legislation or the Human Rights Act torture. But I think the word daylight, you need to unpack it. So there's this window is facing north, so I am getting north light in, and I'm getting lots of light into the bottom of my eye, and we have sensors on the bottom of our eyes, only recently discovered about 15 years ago, that helps define our circadian rhythms. But if I was facing south now, I'd be doing this, and I'd be hot, and I'd be sweating. So, but I'm still getting daylights, direct sunlight or reflected north light. So, and I think, I think the statistic is in the 20th century, 95% of all buildings were built without any consideration of aspect, i.e., is it facing north, south, east, or west? And of course, buildings face all directions.
Yeah.
So we have forgotten. We have forgotten that sun rises in the east and sets in the west, and is in the sky vault juice in the south. And you can design buildings to meet your comfort and health and well-being by having windows pointing north more than they might be south, because then you're getting better quality light in without all of the summertime gain problems that arise and overheat. So daylight for me, we designed the Velux headquarters here in the UK. Velux stands for ventilation and light, VE ventilation, LUX light. And that's a company whose sole purpose is to ventilate and light. Their sole purpose is to sell more windows, but at their corporate core, right in the middle of their brand name, it says ventilation light. And I found working with that, they're a Danish organization, the power of their story about, they talk about bringing light to life, bringing light to you. And so there are organizations who are trying very hard to make sure that light is understood in all its, sounds like I'm doing an advertorial for Velux. There are other roof windows,
yes.
But actually they work very hard to help you understand how that light could support your health and well-being, how the orientation and aspect of that can be modified to change and support lighting the spaces you want to be in.
Yeah.
So, again, I'm talking a lot.
No, that's good. That's what you're here for.
Thank you. You're listening very well. Thank you for listening.
It's interesting. So because in my design, I put very minimal windows on the north side because I was thinking about it being the coldest side of the house and heat loss. Yep. I didn't really think about the light quality, but then I actually, when I chose my Veluxes, I put them on the north pitch of the roof because I wanted that non-direct light. Yep. So it was obviously, it was in there somewhere.
We've got to remember that design can be taught or design can be intuitive. And that, for me, is a kind of intuitive response. So where do I want this to be? I've got a fantastic photograph of a barrel vaulted building, a straw building that we did, which has roof lights, Velux, one pointing due south, one, there are several of them, pointing north. And you can see the color cast difference. One is blue light and one is yellow light. I put it on Instagram fairly recently. And in one photograph, you can see the two different qualities of light in terms of color. And any artist would design a studio with their windows facing to the north because they then get consistent light rather than sunlight kind of jumping up and down and going from 5,000 lux to 300 lux or whatever. So, I mean, I think, and so have you got it to where you want it to be in terms of have you got your balance right?
I don't know. I mean, the windows are ordered. I'll be putting them in soon. I'll find out.
Oh, okay. So you're going to, I hope you do a post-occupancy evaluation of your.
Ooh, tell
new
me
home.
about that. What is that?
So post-occupancy evaluation, designers of buildings quite like designing the building, photographing them before the client moves in, and then hoping they never hear of it again. Fingers crossed, nothing wrong. But post-occupancy evaluation insists that you go back and work out whether the building is performing in the way you wanted. And there are two types of post-occupancy evaluation. There's a kind of statistical and numerical one, which is measuring how much energy it's using and things like that. There is another one by Bill Bordas called the Usable Buildings Trust, where they also don't just look at the numbers, but they ask the humans how they feel. And that's that human-centered design. And on paper, you can have a brilliantly designed buildings, but the humans in them, okay, I don't know, it's pointing the wrong way, or it's I don't like the light, or something like that. And so, again, that's systems thinking. How do you ask the right questions? You need to have the hard numbers. We need to know carbon emissions, kilowatt hours used, et cetera, but we also need to ask the humans, because that's the purpose of most buildings. How do they feel about it? And accept that the answers won't always be good ones, and then say, okay, so how do I design better? Because post-occupancy evaluation should be the input to the next project you do.
Yeah, and a continual
that's how I
improvement. Yeah. Well, I think something that's coming to my mind is and if it sounded like I was knocking architects earlier, it's an incredibly complicated topic.
I knock architects.
You're allowed to, though.
No, don't worry. I'll challenge myself and other architects as hard as anybody else. Yeah.
Great. So we started talking a little bit about Passive House there. I'm intrigued to know your views on that, and whether it's. I was going to say whether it's good or bad. I don't think it's that binary.
No, I think it's great. I was in Germany in 1991 when in Darmstadt, actually. So I was hearing about this guy who was doing stuff around energy use, and I remember seeing somebody saying he's pushed through the pain barrier of insulation to the point at which you don't now need conventional heating systems. And that was a kind of really interesting, oh, wow, pushing through the pain barrier of insulation, i.e. going up with your U values to the point at which you change the system that would demand heating. Mm-hmm. So I think that's fantastic, and it's brought such rigor to the way we analyze buildings. The challenge I have, when it first started, it was a pass-fail thing. You either got it or you didn't. And I was asked to join the founding group for Passive House in the UK. I was busy. I was chair of Wood for Good and a non-exec at Trada, so I was doing too many things, so I couldn't do it. But my feedback at that point was a pass-fail thing is really demotivating if you don't quite get there. But if you got to within 5% of Passive House, you'd already done brilliantly. So
congratulations.
I'm always trying to see. Yeah, absolutely. Wow, you're almost there. That is brilliant. Not you didn't get it. So that binary thing for me, and of course it's gone to Passive House Plus, and Passive House, whatever the next level is. I think what it's brought is rigor and spreadsheets to architects. Architects would normally not go near spreadsheets, the PHP calculations and stuff like that. And I think that has been brilliant because evidence-based work is important. We were the first to certify a Passive House straw bale build system. We did that in 2015. One of the interesting things was, of course, when you're chasing U values, there is a kind of natural material sets which will take you up this high. And then if you want to go higher, your wall has to get thicker, or you have to change your material sets to foams and polystyrenes. Yeah. And because we were set up to not use those, we would have interesting conversations with the guys out in Germany. They said, there's some residual coal bridging here. We could put some a polystyrene strip on that. And we were saying, no. We could do a wood fiber strip. So there was sometimes the number chasing can lead you into material sets that I don't think we should be moving into. And in fact, we need to kind of move away from. But I think that's not about passive house. I think that's about going back to our discussion on why use bio-based or renewable material sets. So that's my view on passive house.
Yeah. How do you feel as a thing, passive house for sort of the masses? Do you think that there's a certain amount of sort of human education needed, or user education, occupant, to actually sort of use the building efficiently?
Yes.
Do you think that's a possible thing for the average human? Because I mean, most of the ones I've seen have been built by the people, built and lived in by the designer. They're into it. They know exactly what to do and what not to do.
We'll be back after a quick break.
Hey there, I'm Mick from the Mick and Pat Show.
That's right, and I'm Pat.
Looking for a podcast that's like catching up with old friends? Well, you're in luck.
We're here to bring you weekly doses of lifestyle commentary, discuss culture and politics, and top it off with the occasional beer and film reviews.
But it's not just about us. We're a community. Our listeners are our kin, and we let you all have a say in what we discuss.
So saddle up and join the conversation at the Mick and Pat Show. You can check out our website or find us wherever you get your podcasts.
Indeed. So they're first movers, and they are they monitor their own energy use, and they post. It's still only 21 degrees C.
Exactly. Yes.
How warm or cold is your house? I switched the heating off, and I'm still at 21.
Exactly.
So all of which is great, but that's not the concern of most people. Lay public.
Yeah.
Clearly, that's not to be rude to the lay public, but I don't understand how my car works. I rely on other people to understand how my car works. So there are two attitudes to this. One, there's a very common excuse that designers of buildings give is to say it's designed to work, but the users are not using it correctly. That's a little bit like the car industry saying the reason why people have accidents is because they're not using the brakes properly. It's quite an easy thing to say and pass off, but in post-occupancy evaluation, you'd have to go back and ask the human why, and mostly they've never been told, or mostly the instructions might be in German, or whatever. So I would say if the construction industry designed cars, we might actually have square wheels. That's how I or the brakes would be in the back or something like that. We tend to not design ergonomically, both for the mental ergonomics of how do you design the systems. So humans are often called the ghosts in the machine. And that architecture is perceived as a machine of elegance. And then, bloody hell, humans become the ghosts who don't use it properly. And I'm saying, well, maybe we've not designed it properly. So why are they not using it properly? And I'm interested in answering that question. I don't know quite what the answers could be, but certainly designing systems where they're designed to work with humans. And it's not just about instructions. It's about where the control pad is. Is it where people would expect it to be? And that's not always the case, and things like that. So I think that's a very complex question, and I enjoy the challenge of saying, how do we design buildings where humans are actually the positive agents of change, not the ones we blame for not understanding how it works? Because there's some research by SIBSI, the Building Services Institute, that showed that humans can double energy consumption or halve it if they understand how the controls are working. So we can, and so I'm more interested in, so how do we do the halving? And even in a passive house, you can use less energy by the humans just deciding to switch things off, not, so I'm interested in how that kind of thinking works. And I'll point you at, was at last week's launch of Learning from Lilac. The University of Westminster, I think, have been working with Lilac, the co-housing project in Leeds. We were the designers and builders, along with others of that. And so that straw, super insulated, almost passive house, community-owned, renewables, PV, all really good. But the thing that makes the hair on my neck stand up is how the people choose to live there. And their carbon footprint is so much lower than I could ever achieve just by designing the system and the fabric of the building. And that is a fantastic unlocking of human potential, in that they choose to live a lower life impact lifestyle. The hardware of the buildings can only take them so far. The rest is them as humans interacting with each other and deciding they're going to get rid of their cars, or deciding they're going to grow their own food, or deciding they're going to. There's an unbelievable amount of bikes. We couldn't design enough bike sheds for them, and still they don't have enough bike sheds. So systems are good, but systems that don't take account of humans is a failed system.
Yes, yeah. Fantastic. I think that's really interesting about the Lilac thing. I'll
send you. It's just come out, and it measures many things over and above carbon and stuff. It's quite an inspiring read.
Fantastic. Yeah, that sounds great. I wondered if because the process of getting Lilac to happen was quite a long thing, wasn't it? You know, lots of investment from people. I wonder if that sort of self-selects the very best type of low carbon liver.
It does. I mean, but even in that, there's a lesson to kind of say, okay, well, if you design the place in which these people can come together and choose to do that, then there is a multiplier effect of them coming together to do that. A lot of people say, I'd never live in Lilac. It's got a laundry and I want to have a washing machine in my house. But that's okay. At that point, I would say nobody at Lilac was marched in with their arms twisted up behind their back saying, they chose to do that. And when you choose to be involved in the design of your spaces and the way you want to live, you can then get multipliers beyond what the hardware can do.
Yeah.
So for some, it might say it's an enclave of middle-class eco-warriors, and they recognize that as a challenge. But the evidence suggests that when a community chooses to live that way, you can get an abundance of better outcomes.
Yeah, fantastic. I can imagine if you were, say, the laundry thing, if you were raising an opposition to that idea, you would hear then, maybe 10 or 15 other opinions that's then going to, make you a better person, because you're more sort of understanding of different viewpoints, and then you're going to choose like the better options, aren't you?
Yeah, and some people walked away quite naturally. They just said, "Well, it's a bit too." Oh my God! People sold their cars to join Lilac because there is a legal obligation to have only half a car per dwelling. They've actually got it down to 0.4 cars per dwelling. So some people chose to sell their vehicle and they carpool. For others, that could be I'm not coming in on that deal, and that's okay. That just calibrates slightly differently. So what I would say to people about Lilac, absolutely, you should challenge all of this, but go and have a look, go and stay, go and talk to people, and trust me, you will be cooler about having a laundry than you could ever imagine. And it's about how people live their lives, and people live their. One of the most common things they say, it's a bit like being on holiday all the time.
Right. Fantastic.
Well, that's quite good.
Well, that's what we want.